In this video, I'm just going to do a couple examples of some harder implicit differentiation problems, especially with the trig functions. I'm not going to post a separate lecture note PDF. I'm just going to do it all right here in the video. Before I do anything super intense, I want to talk about how to use the chain rule with trig functions. I think this sometimes gets a little bit confusing. If you're going to differentiate something like sine squared x 3x, okay, so the derivative of sine squared 3x, power rule, the 2, this is an exponent, becomes a coefficient. Then I have to take the derivative of quote unquote what's inside. So the derivative of what's inside would be cosine times 3. So let me just do a quick breakdown. Technically, that's what sine squared 3x is. Technically, we just don't write it that way. The 2 comes in front, and you just rewrite it. Rewrite what's inside. But then with the chain rule, you take the derivative of what's inside. So the derivative of sine is cosine, then 3x. And then you have to take the derivative of the 3x, which is 3. So the overall derivative of sine squared 3x is 6 sine 3x cosine 3x. Okay, that's going to become important in one of the examples. All right, let's look at number 22. They want to know the slope of the tangent at a specific point. The slope of a tangent at a specific point right away. Derivative. That's the first thing that should come to mind is, okay, I've got to take the derivative of something here, and then we'll move along. So the function they give you. Actually, it's not a function, it's an equation. I didn't graph this in my calculator, but I can pretty much bet that it's not a function. And they want to know the point root 3, 2. All right. So I'm going to take the derivative of y with respect to x, both sides. So luckily, derivative of 5 is 0, so that's going to help us out. The derivative of x squared in terms of x is 2x. Minus, you need to use the product rule. This is x times the derivative of root 3y, which is root 3 dy dx, plus y root 3. The derivative of x, y root 3 is x root 3 dy dx plus y root 3, plus 4y dy dx. The derivative of y with respect to x is dy dx. Well, what's x? I don't know. So the derivative of this variable y in terms of x is dy dx. Now it's a bunch of algebra. So I'm going to have x squared minus x root 3 dy dx. You should just go ahead and do the work. Fast forward the video. Factor out a dy dx, move things right and left. Let's see, how did I do this? I'm going to take the x squared, the negative y root 3, and move them over here. And then I'm going to factor out a dy dx. So when I factor out dy dx, I get 4y minus x root 3 equals y root 3 minus x squared. divide, and we get the derivative of y with respect to x is y root 3 minus x squared over 4y minus x root 3. Okay, I feel like oh, this is not right. The derivative of x squared is 2x. The derivative of x squared is 2x. This should be 2x. And this should be 2x. Sorry, I missed that all along the way. That would have been a pretty big mistake. All right, here we go. Root 3, comma 2. All right, so I'm going to plug in. I'm going to plug in the point root 3, comma 2. So here's my x, here's my y. If you plug into the numerator, you get 0. Plug into the numerator, you end up with 0. I don't care. As long as the denominator is not 0, which it's not, we're fine. Okay, so this means the slope is 0. That means horizontal line. Excuse me. All horizontal lines have the equation y equals some constant. All right, well, the y that was given to us is 2. That's the slope of the tangent, y equals 2. And then the normal line, normal is perpendicular, so perpendicular to 0 is undefined, an infinite slope, that's a vertical line. So the normal is going to be x equals root 3. All right, let's do number 26, which involves a bunch of trig functions. So 26. The first time I did this problem, oh my gosh, I messed it up so bad, and that's because I screwed up the differentiation of the trig function implicitly. I was not happy. I had this whole sheet of work, and then I had to start over. It happens to all of us. X squared cosine squared y minus sine y is equal to 0, and they give us the point 0 pi. Okay. Find lines that are tangent and normal. Okay, here we go. So, I'm going to use power rule, product rule, and chain rule all at once. So, this is going to be x squared times the derivative of cosine squared y. The derivative of cosine squared y is 2 cosine y times the derivative of cosine y, which is negative sine y, times dy dx. Two in front, that's the first part, times the derivative of what's inside. The derivative of cosine is negative sine, times the derivative of the angle. I totally messed that up the first time I did this problem. I dropped the negative sign, and then everything was messed up from there. Okay, so x squared times the derivative of cosine squared y plus cosine squared y times the derivative of x squared, which is 2x. The derivative of sine y is cosine y dy dx. Okay, here we go. All right, I'm just going to go for it. Here we go. I'm going to take out the dy dx. I'm going to take out actually a negative dy dx. That leaves me with 2x squared cosine sine, plus cosine. So I took out the negative, so here are my dy dx's. So I put those out, and I would get negative 2x squared cosine sine. Factor out the negative dy dx, I get cosine y. And that's going to equal to negative 2x cosine squared y. All right, get rid of the negatives. Divide both sides by -1, it's gone. So you get the derivative of this equation with respect to x is 2x cosine squared y over 2x squared cosine y sine y plus cosine y. Wow! Holy cow! All right, divide out the cosine y's. Divide out the cosine y's. So I'm not cheating, I'm just gonna make my life easier. So if I divide by cosine, this becomes cosine y. That cosine y is gone, and this becomes plus 1. I know now there's this gap there, which is irritating, but such is life. Okay, so x is 0, y is pi. So let me just review. This is the slope of the tangent line at some point anywhere on this curve of x squared cosine squared y minus sine y. All right, now I'm going to find out what the slope is at the exact point they asked for. So they asked for 0 pi. Okay, so 2 times 0, when you plug in, you get 0. So the numerator is 0. As long as the denominator is not 0, we're fine, and it's not because plus 1 is going to give me, at the very least, 1. So slope is 0, so this is just like the last problem we did. Slope is 0, therefore it's y equals some constant, in this case pi. The normal is perpendicular, which in this case is the x-axis. Y-axis, sorry, y-axis. Normal and tangent are perpendicular to each other. There you have it. All right, I'm going to do one more of a what do you call it? I'm sure you know exactly what I'm thinking. Second higher order derivative. We're going to do one higher order derivative, and that will be it. Okay, I'm going to do number 40. I try to pick the problems that look the worst, so like the negative exponents and stuff. Hopefully that's helpful. All right, you are asked to find the second derivative. Maybe you are, I don't even know. Oh no, they just ask you to implicitly differentiate. Okay, chain rule. -1/3 times 3 times the base, which is 2x to the -1/2 plus 1. Decrease the power by 1, so that's -4/3. Now take the derivative of what's inside. So 2x to the -1/2, so that becomes 2 times -1/2 x to the -3/2 plus 1, the derivative of 1 is 0. The derivative of 1 is 0. So this becomes -2x to the -1/2 plus 1 to the -4/3 times -x to the -3/2. Negative times a negative is a positive. So this becomes x to the negative 3/2 times 2x to the negative 1/2 plus 1 to the negative 4/3. There you go. That's all we're going to do. Don't be simplifying that or trying to do anything fancy. That is section 4.2.